Alright, it's a video on surface area. This is exciting stuff. You can see I've got a Rubik's Cube right here, height of 4 centimeters, a width of 4 centimeters, and then a length of 4 centimeters. All the sides are the same because it's a cube. That's what a cube does. Surface area. If we're finding the surface area of something, we're finding the sum of all the areas or the faces of that three-dimensional object. So the first place that I would start with any three-dimensional object, if you're not sure, is to make a net of that. In other words, pull that object apart so it looks like a 2D figure. And in the case of a cube, well, what you end up with is 6 faces, 1, 2, 3, and then this guy's opposite right here, 4, and then this guy's opposite right here is on the back, 5, and then this guy's opposite on the back right over here is 6. And so we made 6 faces, and let's label these faces here. So I'm going to call this one, we'll say that this was our face A right here. And we'll put him right in the middle. So if that's in the middle, kind of folded on the sides of it, or this one on the bottom, and this one on the top, we'll call that B, and we'll call the one on the bottom there C. And then also next to A would be squares D and E. And then another one, the opposite of A, way over here is F. So we'll call that F over there. It doesn't matter how we label it. I mean, they're all the same shape. So we got to find the area of square A. Well, that's easy. That's a square. So area equals base times height. Area equals 4 centimeters times 4 centimeters. And of course the area equals 16 centimeters square for square A. Now that was just square A. We've also got to find the area of square B, square C, square D, square E. So I'm going to do that here. Square B will come next. We'll just do them in alphabetical order. In square B we do base times height again, 4 centimeters times 4 centimeters. And we're going to get, you guessed it, 16 centimeters squared. And you're probably saying to yourself, well, why am I going to have to bother making all these calculations for each of these squares, and I just keep getting 16 centimeters squared? And I'm going to say to you, you're absolutely right. Let's stop doing this. Let's not be silly. You can tell, probably right from the beginning here, since it was a cube, that all of these things are going to be squares here. So why don't we just find the area of 1, which is 16 centimeters squared, and then apply that to every other square. So you can see I've got each square is 16 centimeters squared, and we could probably tell this again from the beginning too. Since the cube has 6 faces and each face is 16 centimeters squared, you could just multiply these 6 faces by the 16 centimeters squared. So in other words, 16 times 6, and if you do 16 times 6 out, you get a total area of 96 centimeters squared. So that is the total area of the surface of this shape. Let's try another one. This one isn't a square, it's a rectangle. You can see there's a shoebox here. So I'm going to call this shape right over here, like we said last time, we want to label each side. I'm going to call this shape right here A. And then we'll put A right here since it looks like that's the smallest side. And maybe in the middle we'll have this right here. This would be shape B. So there's B there. And then over on the opposite side, right here, we'll have shape C. And shape C will, of course, go right over there. Shape D, well, really, it looks like shape B was probably our biggest one here. Let me erase this. We'll still call this, let's call this D. Just for the fun of it, we'll call that D. And we'll say D goes up here. And we'll say that E goes up here. So the top and bottom of this are D and E. And then we'll say that part F is right here. And then its opposite is part G right over here. Again, it doesn't really matter what letters we give it. I suppose to keep it alphabetically in order, you could, arrange things so that A and B are next to each other, and C is someplace where you can see it easily. But in any case, it looks like I left out letter P entirely here. No big deal. But the point is that I can clearly see which shapes A and C are very similar to each other, right? So the dimensions of A and C, it looks like it's 8 inches by 6 inches. Shape D, it looks like it's 12 inches by 8 inches. And then shape C, it looks to be 12 inches by 6 inches. I'm sorry, this is a G right here. And shape G is 12 inches by 6 inches. To find the area of rectangle area, I would do base times height. And you can see that the base is 8 inches, the height is 6 inches. And the math isn't quite as simple as the last problem we saw. Remember the last problem we saw that cube and all the dimensions were the same? Well, not all the dimensions are the same here, but if you look at side A is the same thing as side C over here. So we can anticipate that AB would be 48 inches squared, so would C. And then you have side F, which the base and height would be 12 inches and 6 inches, so side F would be 72 inches squared. And then so too would be side G, it would be 72. Well, this came out bad, huh? The inches squared. We'll just write inches squared. Now sides D and E, as you can see in my net up here, they're going to be the same shape and size. Problem is, there really is only one thing marking size D and E because the top of the shoebox is missing. So if you're finding the surface area of this, you've got to be careful. I don't think they want you to find the surface area with D and E because otherwise they'd put the top of the shoebox there. That's not really included as part of the surface of this shape. It's not really there. So I'm just going to find the area of shape D. If the problem asked you, for instance, imagine if the shoebox was closed, how would you find the surface area? Well, then you'd have to include certainly the top and the bottom. You'd include this D and the E. But as it is, I'm just going to find the surface area of D because that's all they give me. So I would do 12 inches times 8 inches and get 96 inches squared. And then finally, to find the total here, we would do 48 plus 48 plus 72 plus 96 plus 72. And if you do all of that out, you should get 336 inches squared. So finally, to find the surface area of a rectangular prism, we would just do the area equals twice the length times the width plus twice the height times the width plus twice the length times the height. And the way we get this formula, as you could probably tell from that last shape, we had two of the same shape here, so we would just do the height times, whatever you want to call this, the length, the width, the depth, whatever you want to call it. You're doing two of these shapes, A and C, and then you're doing two of these shapes, F and G, and then finally two of these shapes, the top and the bottom, D and E. And of course, if, like on the last one, we were missing, the top to a shoebox, then you would just do one of the lengths times the height. But in general, this would be the safe formula to find.